Problem 20 says use a linear approximation or differentials to estimate e to the negative 0.02. So I'm actually going to use linearization. I think that's a little bit easier and faster. So when we're doing linear approximation, what we're really doing is finding the equation of the tangent line at a location of a known value of x that's on the graph of e to the x that's very, very close to 0.02. So for e to the x, I think we need to choose our value a, and we're going to let a be 0. And the linearization formula says L of x is equal to f of a plus f prime of a times x minus a. And you can see this is simply the point slope formula that we use for the equation of a tangent line with the f of a moved over to the right side. So it's essentially solving the point slope equation for y. So we need to find f of a, f prime of a, and we need to choose our a, which we've chosen as 0. So the function that best represents what we're trying to estimate is going to be e to the x. So f of x is e to the x, and our f of a, which will be f of 0, is e to the 0, which equals 1. F prime of x is e to the x, because the derivative of e to the x is e to the x. So f prime of 0 is also e to the 0, which equals 1. So now we have all of the information that we need. So L of x is going to be f of a, which is 1, plus f prime of a, which is 1, times x minus 0. If we clean this up, this simplifies into 1 plus x. Now, if we want to estimate e to the negative 0.02, we can approximate, so I'm using the squiggly equal sign right here for approximate, by this linearization formula. So we simply plug this value, negative 0.02, in for x into our line. And our line simplified into 1 plus x, so that's going to be 1 minus 0.02, and that works out to be 0.98. So one thing to keep in mind on these problems is when people build the formula here, one of the most common mistakes is they'll use the value here for their a. This is not a. This is going to be the x value that you plug into your finished line. You want to grab a known value, and you'll know if you've made this right selection for a if when you're plugging a into the function and its derivative, you can very, very quickly come up with a nice even numbers. So make sure that when you go back and you look at these linearization problems and when you see them on past exams, make sure to notice that pattern, because people often confuse a and what's actually x. So the estimation comes last. After we build the formula, we plug that in for our x value at the very end of the problem.